We previously discussed Facebook, now renamed Meta, which has a presence in blockchain, creative content and consumer hardware, all of which are closely related to the metaverse. In this discussion, I'd like to introduce you to another company. NVidia. As you may be aware, NVidia was once the world's largest manufacturer of graphics cards before becoming the world's largest chip manufacturer. Its graphics cards are primarily used to render detailed and realistic 3D scenes in many big games. You may be wondering what a company that manufactures graphics cards and chips has to do with the metaverse. Why devote a special discussion to NVidia? I have two reasons for this. The first reason is that NVidia is unique among metaverse players in that it is primarily a productivity tool for metaverse developers. The vast majority of overseas players who have publicly declared their intention to join the metaverse are in fact consumer-oriented direct metaverse application developers. For example, Meta the Metaverse scenario demonstrated by Zuckerberg in the video revolves around our everyday life experiences. Such as how to allow people to socialize, work, exercise, play games and so on in the metaverse. Then there's Microsoft, whose metaverse strategy is focused on work scenarios, specifically how to allow people to meet in a virtual space with the image of a digital body. There's also Disney, the entertainment giant, which envisions a digital paradise where fans can dine with Disney princesses. But NVIDIA's approach is distinct from those of the previous companies. It primarily serves metaverse developers or those who create virtual images, digital objects and creative scenes in the metaverse. NVidia provides them with graphics cards and software tools to help them create. When you hear this, you might wonder why a company that makes developer tools deserves your attention. To answer this question, we must consider it in the context of the metaverse's development stage. The problem that the metaverse is facing at this point is that the cost of participation in its construction is too high. If we compare the metaverse to the development stage of a personal computer, it is probably in the early days when computer systems were still DOS systems and you needed a fair amount of computer knowledge to run the computer. The same is true for the metaverse. Those 3 early metaverses we frequently mentioned. If you want to build a house, you must be able to use design software to do simple 3D modeling. Otherwise, it will be difficult for you to build something in it. If you want a small team to participate in the development of the metaverse and create something in it, the tools must be easier to use. NVidia is doing just that, using graphic cards and AI technology to make 3D modeling and image rendering easier for developers, standardizing 3D file formats so that developers using different software can collaborate on the same platform, and so on. It's the same as Apple unifying and simplifying the development architecture of mobile applications so that software engineers can more easily develop apps, and Apple's change ushered in an explosion of cell phone applications. As a result, whether NVidia's tools succeed or fail, their impact on the meta versus development speed is likely to be felt in the future. If NVidia makes the tool platform work well and more developers vote with their feet and use it to develop things in the metaverse, it will speed up the metaverse's construction and development. In a metaverse, how do users typically create virtual items? It must not be done by hand. If you want to build a car that can drive on the street, does the developer use a physical model or another method? How will this car move in the digital world? We must employ professional image calculation and processing software to solve these issues. NVidia has been making graphics cards for so long, and their image calculation And processing capabilities are so advanced that the ability to migrate to the metaverse is completely natural. In this case, we must concentrate on the platform. Based tools released by NVidia in 2019, namely Omniverse. It is software that can be downloaded to a computer or other device which must, of course, have an NVIDIA graphics card. The Omniverse software platform extends the capabilities of the graphics card with a variety of its own and third-party software packages, allowing you to better design things in the metaverse and even create a real-world metaverse simulation in real time. How does real-time simulation work? I'm sure you've seen the video of NVIDIA CEO Jensen Huang speaking for 108 minutes with 14 seconds of real-time rendering of a fake Jensen Huang by NVIDIA using Omniverse in terms of performance. The real-time simulation is the primary difference between Omniverse and NVIDIA's previous game graphics cards. No videos, game graphics cards, for example, are also integrated with physics engine technology, but the movement of virtual objects is pre-programmed by the game developers. For example, a game in which a soccer ball can bounce several times from a high drop to the ground is set. If the calculation frequency is set to 1 second, 50 frames, the soccer ball may bounce 7 times, 1 second, 20 frames may bounce 9 times, and 1 second, 10 frames may go straight through the ground. However, physical processes in the real world are continuous. If you use our universe to create a digital model of a real soccer ball, and then drop it from different heights, the soccer ball will not only bounce in virtual space due to the law of gravity, but the bounces are generated in real time, and there is no way for the developer to pre-calculate the number of times it will move. The soccer ball will bounce several times in the real world, then several times in virtual space until it is infinitely close to the most realistic situation. Of course, real-time physics simulation like this implies that if no videos on Universe ever reaches maturity, it will certainly require much higher computing power than the game. Graphics cards can provide the most valuable application scenarios for our universe in the future. In my opinion, are not just in digital spaces and virtual worlds like games, but in simulating our real world in real time and then solving real-world problems in turn. This is the second reason I'm urging you to keep an eye on NVIDIA. Let's look at a manufacturing company as an example. BMW Motor is currently developing its own virtual factory using NVIDIA's Omniverse, which simulates offline factories one-to-one in real time. According to NVIDIA's demo video, this virtual factory is so accurate that you can see the parts on each car body. Furthermore, the virtual factory's real-time computing capabilities are excellent. The factory's robot arm sees very clearly how to assemble parts, robots see how to distribute materials, and so on. So, once built, what does this virtual factory mean for BMW? It will be able to generate all of the most realistic data in the real factory and then use that data to perform predictive maintenance on the equipment or to conduct realistic tests before the equipment is launched, making it cheaper and more efficient. Consider predictive maintenance. Every car contains thousands of parts, and the more kilometers a car travels, the more it deteriorates. If each component of the car is simulated in real time, the virtual factory will issue early warnings based on historical data, lowering the failure rate and the possibility of safety accidents in the real world. Another example is the car crash test. BMW must produce hundreds of prototype cars and then conduct dangerous crash Tests at a high cost. Now that the test can simulate different environments such as rainy days and snowy days, car collisions and the interior structure of the car. Because the cars in the virtual factory have the physical property of gravity, the collision results are also more realistic, and BMW can then optimize the products more precisely based on the test results. BMW's testing costs will be greatly reduced because the car can be repeatedly simulated and tested in the virtual factory. In addition to simulating industrial manufacturing, Omniverse has real-time simulation application cases in areas such as autonomous driving and virtual architecture. NVidia, for example, used Omniverse to simulate the traffic map around the Mercedes-Benz factory in Germany in real time for autonomous driving. If you own a self-driving car company, you can virtually lease a car and train it in this virtual map space. Virtual architecture is another example. NVidia virtualized the building in our universe before constructing its own headquarters building in California and then simulated the natural light environment in real time to determine what angle the building's roof should be built at, to balance the sunlight shining into the building and find the best solution to save energy. With all of these examples, you may be wondering if what in a video on Universe does isn't what we now call a digital twin, that is like a twin creating a virtual model that looks exactly like a real object. Yes, as we stated in the first lecture of the course, there are two possible paths for metaverse development. The first is a broad metaverse, which is a virtual space-time built entirely in the digital world. The second is a narrow metaverse, which is a metaverse that completely maps the real world. The digital twin, in my opinion, is the core technology that supports the operation of the narrow metaverse. Of course, when compared to the digital twin currently in use, the goal of Omniverse is to achieve more realistic details and add more physical properties to simulate the operation of the real environment, such as light, gravity, pressure, electromagnetic waves and so on, in order to achieve a more realistic effect. Personally, I believe NVIDIA's ability to differentiate itself from competitors lies in this area. In addition to the video Unity and a number of other companies have been working on digital twins and narrow metaverses. However, because the narrow Metaverse will be moving toward more accurate and real-time simulation. In the future, it has been decided that it will be a virtual world that relies more on image computing and model processing. Furthermore, because NVidia has previously accumulated outstanding software capabilities in the graphics card, the application scenario will also run a little faster. To summarize, we primarily discussed two reasons why NVidia deserves your attention at this stage in the Metaverse track. First and foremost, NVidia is distinct from other Metaverse players because it is primarily a productivity tool for Metaverse developers. Second, the Omniverse platform serves as the link between NVidia and the Metaverse. Its most valuable future application scenario is to simulate our real world in real time, and thus solve real-world problems.